Hello, today we are going to talk about Podman. Podman is similar to Docker, is an alternative to Docker. They are both Linux containers. Podman containers usually run as not the user's root, so they're rootless containers. They have an executable, both Podman and Docker. Can be run at the command line with similar command line parameters. So the Podman command line strives to respect the API of the Docker command line. Okay. This is the official website, podman.io. I'm on the Linux operating system Ubuntu 23.10. There's a Debian wiki for Podman. Let's see what the name of the package is for Debian family of Linux operating systems, including Ubuntu. So it's named Podman. So let's install Podman from the command line. The command line is apt install Podman. That's the name of the deb package from Ubuntu and Debian. So that would be sudo apt install Podman. It's already installed. And now it says that both Podman and Docker have a command line parameter which is named search. Search, this is how you see the help of a subcommand such as Podman search. So Podman search and then the search term. Okay, so we're using the Podman subcommand search in order to search for an image. Does not return anything because there's no registry for Linux container images that's known by Podman by default. But if you specify the path of the registry to be used, this search will be successful. And an easy solution to this thing is to tell, for instance, Podman for just the current user that it should know about the Linux container registries docker.io and quay.io. We're going to run these command lines. Okay. And now if we search, for instance, for a container image with Podman in name, we will have hundreds of results. Okay. And the command line of Podman again is similar to the command line of Docker. There's plenty of tutorials for Docker, documentation. Most of those tutorials have you running in the Linux console at the command line various Docker command lines. In those cases, most of those Docker command lines can be run using Podman. You just need to replace Docker with Podman, the string Docker with the string Podman. And if Docker requires to be run as a super user, and the command line starts with sudo space Docker, then there's no need for sudo when you run Podman. So you replace sudo like this, sudo Docker with just Podman. Okay. Let's now follow the official Podman website, which is podman.io. There's the documentation tab at the top of the page. Starts with installing Podman. It's available on operating systems that are not Linux, such as Mac, OS, Windows, and also on FreeBSD as an experiment. It's available in the Linux operating systems, usually in the official package repositories, such as in Debian, in Fedora, in Gentoo, etc. OpenSUSE. We've already installed Podman, again on Ubuntu 23.10. Next up, let's look at the instructions in this starting page for the documentation of Podman. Let's run all of these commands. So podman -help is a way of getting help. You can also specify a subcommand of Podman, such as, I don't know, ls, and get help for that subcommand. These are the subcommands. There's no ls, there's ps, there's image list. Okay, so let's see podman image help. There's the command line for listing images. Next up, there's also man pages, man podman, or the manual for a podman subcommand such as image. Okay, we made search work by adding the Linux container registries for docker.io and quay.io be known by Docker when running as my Linux user account. Let's see how we search for HTTPD. So podman search HTTPD. There's many results, and we can filter by is official. So by not using the filter, we get, I don't know, 80 results. By filtering only by is minus official, we only get the container image for HTTPD, the Apache project. Okay. We can pull, which means getting the layers of the image or the official Apache HTTP, the container image from docker.io container registry. We can list the images. The useful option here is -- all. Okay. So Podman keeps reminding you that docker.io is not the only possible container registry. Don't just use HTTPD as the name of a container image, but specify the full path docker.io/library/httpd. And it also doesn't really recommend that you add a list of known container registries in the configuration file. Okay, so this command line will download the Linux container image, Docker image, docker.io library httpd with its layers. We'll start it, we'll run it in the background, daemon style, detached. We'll provide a pseudo TTI teletype such that we can connect to it, and then it does a TCP port forwarding from port 8080 to port 80 over the TCP protocol. Let's see if I can write the command without. So Podman run minus detached and TTY minus P TCP port mapping slash TCP. So it maps a TCP port inside the Linux container that is running to a TCP port that's available on the host computer. Docker.io / library / httpd. Okay, then it says that because we're running Linux containers not as the Linux user root, we need this software package to be available. Let's see if we have it installed. And it's installed version 1.2.0, which should be at least version 0.3.0. Okay, then we have listed just images until now, but we can also list running Linux containers. So Podman PS, from probably PS, the Unix command line for listing processes, shows the Linux containers that are running. And similar to images, there's also the --all command line parameter that shows containers that are not running, whereas without --all only shows containers that are running. So let's go all. Okay, so now on the hardware computer, on the localhost network interface card loop device, port 8080 TCP, we can access the HTTP server that's running not on the host machine, but inside of the Linux container. And in there, it's listening to port 80 inside of the container, but listening to localhost 8080 on the hardware machine. Okay, let's open this thing with a web browser. And it says that it works. Next up, we have Podman inspect. Says that we have a container running, which is the HTTPD one. Let's see what the name of this thing is. And it's hardcore_fermat. Podman inspect --help. So it's Podman inspect, and then -l is latest. the latest container Podman is aware of, such that we do not specify the name of the container, but we could specify. Okay, so it's a JSON format, arrays, strings, pairs of object, property, name, and value. And in here it says that in order to get at the IPv4 address, we can grep the IP address. And it's empty. So -L is the latest container, but we could have specified the name of the container. So Podman ps --all, the name of the running container is hardcore fermat. And then we can inspect, and the name of the running container. Okay, let's look at the logs. -L latest. Let's use this. This is the Apache HTTP server starting. And then this is the connection log. A HTTP client, which is in our case curl, has connected to the Apache HTTPD server and requested the /URL using protocol HTTP 1.1. Okay. Podman top. What is this? The running processes of a container. Okay. And also we have the option -L for the latest container. So it's running for HTTPD processes with uptime 6 minutes. Okay, let's stop the container. You can stop all of the containers with -A or -all, or just the latest with -L. And in order to list the running Linux containers using Podman, Podman PS will list only the containers that are currently running. So we need to run Podman PS --all in order to see the Linux containers that are not running. So this hardcore fermat is not a Linux container image, it's a Linux container instance. It was running a couple of seconds ago, now it's not running. It says status exited 26 seconds ago. It's still configured, has the TCP port forwarding rule. Okay, let's delete the container. What does Podman RM do? First of all, let's see the images. there's one image, which is docker.io/library/httpd. And then there's this dichotomy between container images and containers or container instances. When you go Podman PS, you're working on container instances. When you're doing Podman image list, you're working on container images. So let's see when we're deleting the container instance. So we have this container instance that's stopped, that's called hardcore fermat. And we have the Podman image, which is this one, docker.io/library/httpd latest. Now we're deleting the last container instance. If we're listing images, there's just the image that we just got from docker.io. If we list the instances, the container instances, there's no container instance, not stop, not running, not nothing. But we still have the image. Okay. Next up, let's look at the introduction. So on the Podman web page, we have this tab Get Started. With installation instructions, we did that. And then in here, we have the same introduction that we saw previously. So getting help for the Podman command lines, searching for container images, downloading container images using Podman pool, listing container images, running a container instance, listing the running container instance, listing the container instances that are stopped, and then we're testing the container. In this case, it's serving HTTP, so we're using an HTTP client. Okay, let's go at the documentation. So goes to docs.podman.io. And in here, we're going to go to introduction. And let's follow this tutorial also. Okay, so it says that we should search for BusyBox. Podman search docker.io/busybox. So it's this one. That we want. And we're going to download this container image docker.io/library/busybox. We're going to start a container instance, and we're going to run it in interactive mode, not in detached mode, so -i, not -d. And again, we're going to create a TTY, and that will place the current terminal inside of the running Linux container, where we can do command line things. So Podman run -i, which means interactive, and t with a TTY teletype, and this thing, the first result in the search. So in here it's downloading the image layers. It's creating a Linux container instance, starting it, and it has connected the current terminal to the inside of the Linux containers. So a Linux container is similar to a virtual machine. So this is similar to me connecting to the virtual machine using, I don't know, SSH at the terminal. Okay. So on my hardware machine, my Linux username is nmariusp. Inside of the container instance, my username is root. I'm in the / directory. Let's see what's available in here. Do we have a Unix shell? Yes, we do. Notice the size of the sh command line shell. It's 1 megabyte and 21 kilobytes. Let's go to the bin directory. Let's do a 3 in here. So there's many of the executables that we know from the base Unix operating system and a minimal Linux installation. There's awk, there's test, there's cat for listing contents of files, copying files, copying bytes from one device to another, disk usage, disk free, text editors, how much RAM and swap do we have, the creator of symlinks, lister of files, extra compressions, man pages, creator of directories, renamers of files or directories, ping, ps3 for listing the processes as a tree, ps for listing the processes, there's even a top for listing the processes in descending order of resource usage, etc. So all of these executables have the exact same size because they're the same executable, which is the executable busybox. That's the way busybox works. If you call VI, it will start busybox in VI mode. Okay. We did what we wanted to do inside of the container. We can create directories in here. We can go cd, goes to the home directory of the current Linux user, which is the Linux user root, which is the /root directory. We can create directories in here. Do whatever we want. We can download files using wget. We can unzip them. We have text editors. We can create empty files. Many minimal Unix userland command lines exist in here in this container instance. Okay. We will exit the connection that we have to the container, similar to stopping the SSH connection to a virtual machine using the exit command. Now the terminal is back on my hardware machine. Next up, it's showing how we can create container images. So we can download container images, but we can also create container images by using the file named Docker file or container file. The same content, just the name is different. So this is the old standard name, Docker file for Docker, but container file is also allowed, at least by Podman. Okay, let's look at such a container file or Docker file. So it's the name Docker file from the GitHub repository Nginx incorporated Docker Nginx. And it says download from docker.io registry, container registry, the container image named Debian with the tag buster-slim, and then give it a label, define 3 environment variables or variables, and then run this huge, where are you? Command. So this huge shell script is run at once as one entity. Where this is a command, this creates a Linux user group named Nginx with group ID 101, 101. Then it creates the Linux user Nginx with user ID UID 101, which cannot log in interactively, which does not has this interesting home directory, which is part of the Linux user group Nginx. And then because it's Debian, it's working with remote repositories for deb packages from Debian. It fetches the latest list of available deb packages in the remote repositories, apt-get update. And then apt-get install will install the following packages: GNU PG1 and CA certificates in order to have HTTPS work at least in curl and wget. Then it's adding to the apt the list of signatures known by the apt package manager. These GPG digital signatures. Then it removes GNU PG1 deb package from the system. It cleans up the system, the package manager, cache, etc. So it's doing all sorts of work in order to install on top of a plain, simple, minimal Debian Linux container image for Debian. It's going to put the Nginx HTTP server on top. Okay, so it finishes running this huge shell script in here. Then it's doing symlink between /dev/stdout and this text file, and symlink between /dev/stdr to this file. So this is file descriptor 1 and this is file descriptor 2, stdout and stdr. Then it's exposing TCP port 80. And it's running inside that Linux container just one process, which is nginx -g daemon off. And then this process might spawn child processes as needed. Okay. So let's see how we're creating locally an image based on this recipe, on this Docker file. Podman build -t, which is the name of the image, and then the URL. We could specify the shortened URL, the full URL, or we could just download the Docker file locally and tell Podman build to use it. So because it has both docker.io and quay.io does not know which one to select, it suggests docker.io first, which is yes, that's what the nginx project wanted to do. Okay, so these are the steps that we saw in the Docker file. It set a label, environment variables, it's running this huge script. In here, it's installing a ton of deb packages, which is where setting up CA certificate. So this part, this guy. Okay, this part is this part. And it has failed with exit status 1. Well, it should have failed because Buster is a very old Debian version. So Buster is Debian 10 and the current version of Debian stable is 12 bookworm. So Podman should really update their documentation. Okay, but once you have, if the Docker file works correctly, it will create a local image named nginx, and then we can start a container instance using the container image nginx. In here, it's running it in detached mode, so not interactive, doing TCP port redirect such that we can connect to localhost with a HTTP client on port 8080, and that will be redirected to the container instance port 80. These are advanced functionalities where you connect to container registries in order, for instance, to publish container images or to fetch non-public private, so non-public, therefore private container images, for instance. Let's see if I can manage to build a random Docker file using Podman. These are the KD GitLab CI container images. Let's go, for instance, with OpenSUSE Tumbleweed Qt6, which looks like this. Let's download the file. How do we do that? Raw. So I'm saving the raw version of the file. Let's switch to this directory. Let's look a bit at the Docker file. So says that's going to download from docker.io the container image OpenSUSE, the tumbleweed version, which is a Linux operating system that's a rolling release. And then it's running Zypper, which is the package manager, to add a RPM repository, which is this one, kd-qt6. I'm not sure if this thing will work because, for instance, in GitLab CI, you can, when creating Docker images, you can pass external resources such as environment variables, etc. But let's just try. So in the current directory, we have a Docker file. We need the command line Podman build. Let's look at its help first. Says Podman build, and then we can provide the current directory. It will search for container file and probably also Docker file by default in the provided directory, which dot is the current directory. Or you can specify the name of the file -f and then the name of the container file. You can also specify a image name with -t. Okay, so let's do this, but with a -t. So Podman build -t OpenSUSE tumbleweed Qt6 and then the current directory. Again, because we have quay.io added there, I pressed enter to select the default, which is docker.io. Let's look at what it's doing. It's moving way too fast. So it's adding the digital signature keys, which is probably this thing. And right now it's installing 1,000,000 RPM packages, which is probably this part and this part. And this part and this part. So all of the Zypper in. Zypper is the RPM package manager for OpenSUSE. In means install. So you can go Zypper install or Zypper in. It's the same thing. In is just the short version for install. Okay, so we did Java, which is this thing. Now it's probably doing this part with ffmpeg. It's first retrieving and then installing the packages. So for this command line, you need to download 114 RPM packages, and then it's installing them. Next up, installing a C++ development toolchain for the C programming language and the C++ programming language. Installs many devel RPM packages. Okay, GCC 12, the C++ and C compiler. Open SSH server, Bison parser, flex parser, Perl programming language, the auto tools from GNU, Perl modules, Git, network manager. Okay, so it downloaded 181 RPM packages and now it's installing them one by one in the correct order, of course. Okay, next up, it's installing the development RPM files for Qt 6. After each of the lines is run, so after line 18 is run, it wrote this thing, this hash sum, which is a layer in the container image that's being generated. The container image is not just one file, but a layering of images, of layers, and this is the one of the layers. And then it's doing the next layer, which is this one. Okay, then it will run this command, run zipper, install git clang ninja python package manager, upstream, and more Qt 6 RPM packages. So now it's downloading and installing 609 RPM packages for Qt 6. Either this part or this part. Let's see if it does git now. Yes, this is the one. Because I can see upstream. So it's installing, I don't know, 3000 RPM packages in order to make the bare bones OpenSUSE tumbleweed Linux container image have enough RPM packages inside installed in order to build any KDE software from source code. Okay, so those were 147 dep packages, this line 22 until here. Okay, then it's going to install Python pip packages, then more installing RPM packages, Perl modules, Wayland, and random RPM packages that are needed by various KDE Git repositories. For instance, the KDE Git repository Sonnet needs the spelling library aspell with its development RPM package. Okay, so that's the way it's going to go. Finish installing RPM packages at line 350. And then It's making Linux dbus work. It's creating an X11 socket, something like that. Creating a Linux user group host video. So this is for audio and this is for video. Everything until now was run as the Linux user root inside of the Linux container instance, and then it switches to an unprivileged user, which is named user, which has been created here, where it says user add user with this home directory using the shell usr bin bash, member of these important Linux user groups. The home directory does not exist, so it's going to be created. And this magic UID, user ID 1000. And that's it. At the end, if we're going to run Docker images list, we're going to see the image there. Or in our case, we're going to replace Docker with Podman, so Podman images list. So this is it. This is how you download Linux container images from container registries using Podman, how you create Linux container images using Podman build, how you take an existing container image and start a container instance using Podman run, how you list running container instances using Podman PS, how you list downloaded or created locally Linux container images using Podman images. And then clean up using Podman stop -a to stop all of the Podman stop -a to stop all of the running Linux container instances. And you can even go Podman images remove, so rm -a to delete all of the images. This is it. Thank you.